Hi, welcome to clickmeproject.com. Now we are going to learn about a software engineering paper, a UMLMARTE model analysis method for uncovering scenarios leading to starvation and deadlock in concurrent systems. The main objective of this paper is to detect the concurrency problem, which is nothing but deadlock and starvation. First of all, we have to know what is meant by deadlock and starvation. Starvation is a resource management problem where a process does not get the resource. It needs to wait for a long time because the resources are being allocated to other process. In the case of deadlock, deadlock is a state where two or more operations waiting for each other to finish and thus never does. For effective detection, we have to devise a solution that is applicable in the context of UML design of the concurrent system without requiring additional modeling. And also, we have to use a searching technique to achieve scalable automation in terms of concurrency problem detection. For our first objective, we are going to apply multi-model analysis in the UML context. For our second objective, we are going to use genetic algorithm to search for execution sequence exhibiting deadlock or starvation problems. That's it from the part of abstract. Let us see the data flow diagram of our implementation. The data flow diagram starts with the input of UML concept. From the UML concept, we are going to design a UML diagram. The UML diagram is given as an input to the MARTE mapping. The context from the UML diagram is extracted and it is mapped to the MARTE tags. The output of the MARTE mapping is given as an input to the genetic algorithm. According to the genetic algorithm, we are going to initialize the search space. Then it is going to be crossover and mutation. From the result of the genetic algorithm, we are going to detect the deadlock and starvation. That's it from the data flow diagram. And now we are going to see the exclusive demonstration of our implementation. We are using NetBeans IDE to design our project. In our project, first we have to run flow.java. The process starts with loading the UML data as an input. I had already stored the UML data as a text file. Now I am going to construct the UML diagram for the loaded UML data. The input taken in our process is a dining philosopher problem. The philosophers are the threads and then forks are the logs. Let us have a closer look over this process. I am reading the UML and extracting the UML concepts. After extracting the UML concepts, we are going to map the MARTE tags to the UML concepts. After applying the MARTE tags, we are going to construct the new UML MARTE diagram. Then we are going to generate the search space. The search space is nothing but the possible solutions for a particular problem. For generating the search space, we have to give number of threads as an input and number of logs and the total time limit. So based upon these parameters, I am going to generate search space for GA. GA is nothing but the genetic algorithm. The generated search space contains sequence of chromosomes. Each chromosome consists of threads, logs and access time. Now we are going to enter into the genetic algorithm process. The genetic algorithm first step is initialize population. I am going to initialize population based upon the random parameter. The loaded population is 39. Now I am going to apply crossover for these chromosomes. All population and then apply crossover. Crossover is nothing but that generating new chromosomes based upon the already existing chromosomes. The next I am going to mutation. Load population, mutate chromosomes. Here mutation process, we are going to mutate the duplicate chromosomes and also invalid chromosomes. The next detection. Load chromosomes. Then I have to give a particular log as a input. The chromosomes which contains L4 as listed below. Now I am going to schedule this process. For scheduler, I have to select an input sequence. After selecting the input sequence, I have to schedule those threads. Now the chromosomes are scheduled successfully. It contains executing threads, and then access time for the executing threads, and then waiting threads, and then access time for the waiting threads. So based upon this, we have to execute these chromosomes and then check whether deadlock and starvation is present or not. For this process, we have to give target thread as an input. Here I am giving T5 as a target thread, and then I am going to select time interval 0 to 50. So the detection mode I am selecting here is starvation. So I am going to check whether starvation is present or not. So here starvation detected at 55. The next I am going to select deadlock. Here I am checking whether deadlock is present in this sequence or not. So deadlock also detected in this sequence. Now I am changing the time interval from 50 to 55. Now I am checking whether starvation is present or not. The sequence is executed successfully with a fitness value of 325. And now I am going to check whether deadlock is present or not for this sequence in this time interval. So the threads are executed successfully. So there is no deadlock and then there is no starvation. That's it from the demonstration. Thank you for listening the video.